Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is quadratic equation. What we are going to discuss today is the completing square method. So let's begin. After completing the very lesson today, my dear student, will be able to find the solution of a given quadratic equation using the completing the square method. This is what I hope you'll be able to do after completing the very lesson today. My dear student, as usual in a favorite segment of the lesson, today I'm happy to give you another interesting number. This number is 27. 27 is so unique, so amazing, so interesting. I'll tell you what is interesting about this very number after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us learn the rule. It is this rule that will guide us what we need to do in attempt to find the solution of a given quadratic equation using this method of completing the square method. So let us learn these rules. So rule number 1 says make the coefficient of the squared term unity. That is, you have to make the coefficient of that is your square term 1. When that is now done, step number 2 says get only the x square and the x the terms on the left hand side of your equation. That is your square term and the term containing that letter in your equation. Try to bring them to the left hand side of the equation. Well, now that is done, step number 3 says make the left hand side of the equation a perfect square trinomial. So when you bring the square term and the term in x, you now have just the two terms by the left hand side. So that binomial, you have to make it into a perfect square trinomial. That is your left hand side of that very equation. You make it into a perfect square trinomial, which we have just learned in our previous lessons. When that is now done, step number 4 says you now factorize that left hand side. We also learn how to factorize our perfect square trinomial. And step number 5 now says apply the able root property, which we shall see. The able root property is just taking the square root of both sides. When that is now done, you now solve for x. These are the 6 steps that we have to take in order to find the solution of a quadratic equation using this very method of completing the square method. We are going to take examples how we can make use of these 6 steps and find the solution. So let's just move. Example number 1, it says solve the 2x squared plus 3x minus 2 equals to 0 by the method of completing the square method, which means you have to find the solution of this very quadratic equation using this method. So solution to this very problem, copying the given quadratic equation, that is 2x squared plus 3x minus 2 equals to 0. So rule number 1 says we have to make that square term, the coefficient there, make it 1. I have 2 here as the coefficient of x squared, so I'm going to make it 1. How I'll make it 1? I'm going to divide it through by that very coefficient. Let me do that. So I'm going to have x squared after dividing through by 2. 2x squared divided by 2 will be x squared plus 3x divided by 2 minus the 2 divided by 2 gives you this minus 1, and 0 divided by 2, of course, is 0. This is step 1 is now complete. Step number 2 says you have to now bring all the square terms and the term with that very letter in your variable on the left hand side and all others now to the right hand side. So I'm going to leave this x squared and 3x over 2 by this left hand side, which means this minus 1, I'm going to transfer it to the other side. So let me do that. So I'm going to have x squared plus 3x all over 2 equals to 1. I have shifted this minus 1 to the right. I just want to see term in x and the square term by the left. So I just have 2 terms here by the left, which is mean this is a binomial. So I'm going to make it into a perfect square triangle. So I'm going to add another term here to make it a 3. And after adding that suitable term, it is now going to be a perfect square, which we have learned in just our previous lesson. So what I'm going to do, I'm going to make this a left-hand side perfect square trinomial. Remember what we needed to do. Identify the coefficient of x, which is 3 over 2. Get half of it, which will now be 3 over 4. and square that result. Is what we're going to add here to make it perfect square trinomial. Let me do that. So I'm going to have x squared plus 3x over 2 plus 9 over 16. This 9 over 16, if I repeat, I said have the coefficient of this x. The coefficient of x is now 3 over 2. Half of it will now be 3 over 4. When you square 3 over 4, it's going to give you 9 over 16. So it's 9 over 16 that we are going to add to this left-hand side. Of course, because you have an equation, for this equation to balance, you have to add also the same number, 9 over 16, to your right-hand side of the equation. So this, my left-hand side, is now exactly a perfect square trinomial. What I'm going to do next is to just write it as factorization. The factorization of this is now going to be x plus 3 all over 4 in the bracket, and that bracket raised to the power of 2. If I repeat, what we usually write in the bracket is x. If it is plus, separating the square term, and the term with the letter is plus, write plus. If it were minus, write minus there. And the next term in this case is 3 over 4. And this 3 over 4 is nothing but have the coefficient of x. Coefficient of x, remember, is 3 over 4. Half of it will now be 3 over 4. This is what we usually have in the bracket, the rest of the power of 2. And adding the right-hand side, that is 1 plus 9 over 16, gives you 25 over 16 if you do it using LCM. So next is to take the even root property. That is just to take the square root of both sides so that you eliminate this power 2. Let me do that. So I'm going to have root of left-hand side is now root of x plus 3 all over 4 whole squared equals to root of 25 over 16. So I'll continue. You can see power 2 will now cancel the square root. You're just going to have x plus 3 all over 4. And taking square root of 25 over 16 will give you plus or minus 5 over 4. So I'll continue. So I'm going to solve this very well. After taking the root, so I'm going to take this 3 over 4 to the left-hand side. That will leave me with my x only by the left. Let me do that. So I'm going to have x equals to minus 3 over 4. This 3 over 4 that I have shifted is now changed to minus. So I have written it first because this 5 over 4 is either plus or minus. So let me leave it in between the two. So I'll continue. So this says x is now equals to either minus 3 all over 4 plus 5 over 4 or minus 3 over 4 minus 5 all over 4. Let me take whichever the case. So I'm going to have x equals to minus 3 over 4 plus 5 over 4 or x equals to minus 3 over 4 minus 5 all over 4. This will now be my result. And then addition of this correctly, you now have x equals to 2 over 4 or x equals to minus 8 all over 4. And simplifying 2 over 4 gives 1 over 2. And simplifying minus 8 over 4 gives minus 2. Example number 2, it says you have to solve this quadratic equation that x squared minus 6x minus 4 equals to 0. And this also we have to use the completing square method to find the solution of this quadratic equation. So solution to this very problem. Copying the given quadratic equation that x squared minus 6x minus 4 equals to 0. What we do first is to make the coefficient of the square term, we have to make it 1. In this case, it is 9, so I have to have 1 here. So what I'm going to do, I'm going to divide it through by 9, everything divided by 9. That will gives me x squared. After dividing 9x squared by 9, gives me x squared. And dividing minus 6x by 9 will now reduce to minus 2x all over 3. You can see 3 in 6 gives you 2, 3 in that 9 gives you 3. Then minus 4 over 9 equals to, of course, 0 divided by 9 gives you 0. So I'll continue. So what I'm going to do next is to now allow only x squared and minus 2x over 3 by the left-hand side. This minus 4 over 5. This minus 4 over 9 will now be shifted to the right. So let me do that. So I'm going to have x squared minus 2x all over 3 by the left, because the rule says you just get your squared term and the term with that letter x by the left. All others will now be shifted to the right. So you now have 4 over 9. by the right. So what I'm going to do next is to make this left-hand side, this binomial into a perfect square trinomial. So I'm going to add a suitable number here so that it now becomes 3 terms, and that 3 terms will now be a perfect square. How we get that number, remember in our previous lesson, my coefficient of x, which is now minus 2 over 3, minus the 2 over 3, that is the coefficient of x. So I'm going to half it, meaning divide it by 2. After dividing minus 2 over 3 by 2, you're going to have minus 2 over 6. And that minus 2 over 6 is now going to be 1 over 3 again. And you now find the square of that 1 over 3, which gives you 1 over 9. It is 1 over 9 that you are going to add to this left-hand side. Of course, you are going to add it also to the right, so for the equation to balance. Let me do that. So I'm going to have x squared minus 2x all over 3 plus 1 over 9. That is the square of half the coefficient of 2 over 3 equals to 4 over 9, which I just copied, plus 1 over 9, the 1 over 9 that I have added here for this equation to remain balanced. So this, my left-hand side, is now perfect square trinomial. If it is perfect square, then I can now factorize it. So let me just write the factorization of this one now. Let me write the factorization is now going to be x minus 1 over 3. Remember, 1 over 3 is that half the coefficient of x. The coefficient of x is 2 over 3. Half of it, which I said is will now be 1 over 3. So it's what we usually write in the bracket. And this is minus because the sign is separating your square term, and the term with this letter x is minus sign. And this is equals to 5 over 9. 5 over 9 is a result of adding this 4 over 9 and 1 over 9. So what I'm going to do next is to apply the even root property, that is to take the square root of both sides, so that I'll eliminate this power 2. Let me do that. So I'm going to have root of x minus 1 over 3 whole squared equals to root of 5 over 9. You see this power 2 cancel the square root, so you're going to have x minus 1 over 3 equals to plus or minus root of 5 all over 3. It's not 5 is not a perfect square number, so you leave it in the root form, but the square root of 9 gives you this 3 outside the root. So what you now do, you have to take this 1 over 3 to the right hand side. There will leave you with x alone. So x will now be equals to 1 over 3. This 1 over 3 minus shifted to the right becomes positive. So I have 1 over 3 plus or minus root of 5 all over 3. So this, the solution says x is either 1 over 3 plus root of 5 over 3 or 1 over 3 minus root of 5 all over 3. Let me just write it. So this is the solution, x equals to 1 over 3 plus root 5 over 3 or x equals to 1 over 3 minus root 5 all over 3. This is where you're going to stop, because this root 5 you cannot evaluate it, and unless if the question says give your answer in decimal. So this is how we now find the solution of quadratic equation using the completing the square method. With these few examples, I hope you'll be able to find the solutions of any quadratic equation using completing the square method. Let me just move to the last segment, maths is fun, and I explain what is interesting about the number 27. 27, it says, is the sum of it is the digits in it is a cube. That is, if you are to find the cube of 27, add those digits in the result, what you get is the number back. Let's just find what is 27 raised to the power of 3. That is 27 cube means 27 multiplied by another 27 multiplied by another 27. If you do that correctly, it will have, you now have this number 19,683. And if I add those digits in this cube of 27, what I expected to have according to this very property of this 27 is the number back. So let me add those digits. 1 plus 9 is 10. 10 plus 6 is 16. 16 plus 80 to give me 24. And 24 plus 3, you get your number back, which is 27. So 27 is very, very interesting number. We see more of these things in mathematics in our subsequent lessons.